Hey, pre-calculus, here we are in section 3.6 looking at critical points and extrema. Our vocabulary has a lot of terms, and I think that the best way to do it would be to kind of create pictures. So I'm going to draw a few shapes, a few figures to kind of help us understand exactly what we're looking at. So if I were to consider these three graphs here, I would consider certain spaces to be what we call critical points. So a critical point is wherever I can draw a tangent line at just one point on a graph such that it is horizontal, as I have here, or this is another situation where it's horizontal, or vertical, as I have here. Notice I'm technically trying to draw a line through one particular point. And so these critical points on the graph are, just as we said, sometimes they can be maximums, they can be minimums, or they can be points of inflection. So hopefully it'll be clear as you just look at the graph what we're talking about. So a maximum would be a place where it is high. Actually, this is a relative maximum because it's not the highest place. But a maximum would be like here, or if I had an unhappy parabola, that would be an absolute maximum. That's some more vocabulary we're going to get to. Another term is a minimum, and this is not an ultimate minimum. It's a relative minimum. So I'm going to point to this one. This is a real minimum. All right. And so we've got a minimum. It is the absolute minimum. We have a maximum. It's kind of a relative max. We'll talk about that a little bit more. And then we have this idea of a point of inflection. The point of inflection will be better explained to you later on. It has to do with, like, this is kind of like an upside down bowl, and this is like a right side up bowl. What you're going to notice when you have a point of inflection is something called, we're not talking about it now, but concavity on either side of the point of inflection is going to be different. We have a change in concavity. But this line right here, this tangent line passing through this one point such that it is vertical, tangent line, is considered a point of inflection. So what you'll notice here is that we have, this will be an absolute maximum. This is an absolute maximum because it is absolutely the highest point on this graph. And this would be an absolute minimum over here as we're dealing with the absolute minimum of the graph. And each of these are called the extremas, or they're called extremas or extremum. The singular form is extremum. And so they're just kind of, when I think about the word, it sounds like extreme, right? It's like an extreme place. It's like where an outlier in a sense. So when I think about that, what I'm going to talk about, all of these are going to be extrema in reference to these graphs. So if I had another graph, let's go ahead and give some funkiness like that. These guys that I'm going to color here in dark blue, these are relative maximums because they're maximum relative to what's going on around them, right? So we have some relative max there, and then we have relative minimums, and I know you get it already. This is a relative minimum. It's not the lowest place, but it's a relative minimum. Let me see, relative minimum. And so all of these are really relative extrema. They're not necessarily the maximum or minimum for the whole graph, but they are relative maximums and relative minimums. And I made too many XY axes. I don't think I need them to show you anymore. But we could have all kinds of graphs that kind of display that. Sometimes you'd have like a V, an absolute value graph. You could have some kind of funky piecewise function graph. Ooh, the computer's doing funny things for me. And then we could have something like that where you would consider this a relative minimum. Up here would be a relative max. So as you notice, a lot of these words, critical points, all of them are critical points, and a lot of them have different definitions depending on their location and how they frame the graph, all right? So we'll get started with some examples. So here in example 1, we are asked to locate the extrema for the graph, and so we know that that would be these places here. And then name and classify the extrema of the function. So we can say that, what would you say negative 3, 1 is? Negative 3, negative 3, 1 is obviously a low place, so it is a relative minimum. Right? We know it's a critical point because we'd have to be able to put that, we have to use a horizontal line for the tangent line to that point. And over here, we have a relative maximum with 1, 5. And then we have another relative minimum here with 4, negative 4. I'll write it as a relative min. All right. So with this graph, with this one, we were asked to use a calculator to, figure out what the extrema is. And honestly, this is kind of a slightly dated question in that it's so easy to do this now that what the text wanted to do in this, what the authors of the text wanted to do, is to show you how to use like a TI-85 or a TI-82 calculator or whatever. And so we're probably going to use Desmos. So what I did is I just plopped it in Desmos, and we see that they've given us the extremas here. Let me think, what did they classify the extrema? I also think somewhere here would be, this is just for our conversation, it's not an extrema, but we'd have a critical point, because I think if we were to continue writing, we could see that we'd have a tangent line that would kind of cut through the graph like that. That's just for your eyes, just for you to think about it. But they asked us to determine and classify the extrema. So when we graph it, we see that we've got this high point. Click on it on Desmos. They give you the exact value. So we will call this a relative maximum. Relative max. This graph doesn't have an absolute max or min because it continues on in each direction, but it does have a relative max and a relative minimum. All right. Here in example 3, we're looking at this function and we're going to determine, and they give us that there are critical points at -1, 0, and 3. And we're going to determine whether each of these critical points is the location of a maximum, minimum, or a point of inflection. And if you think about what those things look like, a maximum is going to be like this, a minimum is going to be something like this, and then a point of inflection will be something kind of like, let's see, something more like where we've got this change in concavity. So something kind of like that, something there. And what you'll notice is that on either side of a max, our values for the function are lower than at the max. And on either side of a min, our values for the function are higher. And on either side of what we would call a point of inflection, our values are, one's higher and one's lower. So we're going to use that information, that thought process, to consider what's going on here. So I'm going to rewrite this function. So what we want to do, I made a little chart, rewrote the function, and we're going to plug in the -1. And when we do that, we end up with the number 3 if we plug that in. Then when we plug in 0, knowing this is a critical point, we get 0. And when we plug in 3, we get -189, all right? So after those values, what we want to do is check values that are really close, as we talked about before, to determine what's going on. So I'm going to choose like -0.9 and maybe -1.1. Over here, I'm going to choose maybe 0.1 and -0.1. So I'm on either side of that 0. Over here, let's choose 2.9 and let's do 3.1. We're going to plug those values into the function, check out what we get, and then we're going to determine from that information what situation do we have. Do we have maximum, minimum, relative max, relative min, or if we have an inflection point. So if you take a look at our values, you can kind of see a little bit better what's happening, even without graphing. So the first thing we want to recognize is that since this 3 is the critical point, this -1, 3, we see that on either side, the values are lower. Therefore, remember, if we have a higher number and then on either side the values are lower, we have a relative max. We're going to check out this next one over here. If we have 0 and then on one side it's less than 0 and the other side it's greater than that value, right? So we plugged in 0, we got 0. So on one side it's less than, or on one side it's greater than. We know that we have an inflection point. And then this final example over here, we realize that we have negative 189 and negative 187 and negative 187.3 and zero point 0.1 is actually higher. Think about it for a second. It's negative, so it's higher up. And therefore, we have a relative minimum. That's a relative min. All right, so we didn't actually have to graph to find that answer.